Hello everyone, I'm Vivian Chan. Today in this video, I'm going to explain it to you HSC 2018 Mathematics Extension 1 Question 14. Question 14 is the last question of this paper. Question A. It tells you that there is a quadrilateral A, B, C, and D, and then at each vertex there is an angle bisector drawn to the angle, and two of the angle bisectors intersect at one point, just like AQ is the angle bisector of angle A, and then BS is the angle bisector of angle B. These two angle bisectors, they intersect at P. And similarly, we have intersections S, R, and Q. These four intersections, they form an other quadrilateral. The question asks you to show that this quadrilateral is actually a cyclic quadrilateral. What makes a quadrilateral cyclic? You can draw a circle passing through this quadrilateral, means the points of the quadrilateral lies on the circumferences of one circle. What are you going to do here is you have to show that this PSRQ quadrilateral, it obeys some circle properties, such as if angle APS is actually equals to this angle SRQ, then they satisfy the circle property about exterior angle equals to interior opposite angle of a cyclic quadrilateral. Now I have these two triangles highlighted, one in blue, one in green. Let's take a look at the blue triangle first. If this alpha plus this beta, they sum up to be angle APS, because angle APS is the exterior angle of this triangle ABP. Let's now look at this green triangle. This angle SRQ should be equals to this angle DRC. They are vertical opposite angles. This angle DRC in the green triangle should be equal to 180 minus delta minus gamma. It is angle sum of triangle. Since these two angles, they are equal, therefore we can conclude that angle SRQ is also 180 minus delta minus gamma. And now let's take a look at this quadrilateral ABCD. The four interior angles should be summed up to 360. This is the angle sum of a quadrilateral. And now we can see all the alpha, beta, gamma, and delta. We have 2 for each. Let's just take out this 2 as a common factor and divide both sides by 2. We know that the sum of alpha, beta, gamma, and delta should be equal to 180. Then transpose gamma and delta to the right-hand side. You will have alpha plus beta equals 180 degree minus delta minus gamma. So we have done. As we know that angle APS equal to alpha plus beta and angle SRQ equals to 180 minus delta minus gamma. Therefore, we can conclude that angle APS should be equals to angle SRQ. Just like we have mentioned at the very beginning, if these two angles equal, then this SPQR should be a cyclic quadrilateral because exterior angles equals to interior opposite angles. Part B1 asks you to use binomial expansion to expand this bracket and this bracket so that this equation holds. Let's take a look at binomial expansion. 2 plus x is binomial to the power n. We are going to expand this. It should be equal to summation r counted from 0 all the way to n, NCR2, the first term, to the power n minus r, and then x, the second term, to the power r. What does it mean? It means r is a counter started from 0. So the first term should be NC0, 2 to the power n minus 0, and then x to the power 0 means 1, so nothing's here. And then the second term, and r equals to 1, so it should be NC1, 2 to the power n minus 1, and then x to the power 1. So the coefficient started from NZ0, NZ1, NZ2, next one should be NZ3, NZ4, 5, 6, 7, all the way to N. The power of 2 is decreasing from N minus 1, N minus 2, N minus R, and then all the way up to N minus N, become 2 to the power 0, which is 1. And this x power is increasing from 0, x to the power 0 is 1 here, so you don't see the x, and then x to the power 1, x to the power 2, 3, 4, 5, and then to the power r all the way to the power n. This is binomial expansion. And the second polynomial that we are going to expand is not a binomial, it is a trinomial, but we can still try to divide it into two parts. First part 1, second part 1 plus x. Similar to what we have done, summation from r equals 0 all the way up to n. The coefficient should be NCR. The first term is 1, 1 to the power n minus r. The second term is the bracket 1 plus x to the power r. Since 1 to the power whatever, it goes always to 1. 1 times any number, it goes to itself. So we can just ignore this term. So starting from 0, first of all, it should be NZ0, 1 plus r to the power 0. It is still 1. Anything to the power 0 is 1. So we just have NZ0. Next one is NC1, 1 plus x to the power 1. This one is always 1, so we just ignored it. Next term, NC2, 1 plus x to the power, the r equals to 2. Power 2, power 3, 4, 5, 6, all the way up to r, and then up to n. This is the expansion of this bracket. Since this 2 plus x and this 1 plus 1 plus x, they are actually the same thing. Let's compare the coefficient of xr. Here we have 1 plus x to the power r. We still need a binomial expansion before we can get to the coefficient of r. 1 plus x to the power r, the expansion rc0 plus rc1x all the way to rcr to the power xr. The coefficient of xr is ncr times rcr. Let's take a close look at the expansion of this 1 plus 1 plus x to the power n. The power of 1 plus x goes from 0, power 1, power 2, power 3, 4, 5, and then power r plus 1, power r plus 2, all the way up to power n. So here in the first term, we do not have any x. The x power equals to 0. Here, the power of x equals 1. Here, the highest power of x goes to 2. In this term, the highest power of x equal to r, which means before this term, all the power of x should be less than r. How about after this term? The next one should be NCR plus 1 times 1 plus x to the power r plus 1. And in this expansion, the highest power of x should go to r plus 1, which means before r plus 1, you should have x to the power r. Therefore, in all the expansions after this 1 plus x to the power r term, you should always, in each expansion, find a x to the power r term. And the coefficient of them should be in the form like NCR times RCR and NCR plus 1 times R plus 1 CR. And the next one should be NCR plus 2 times R plus 2 CR. Therefore, in this expansion, the coefficient of x to the power r should be, they are a little bit complicated. It should be NCR times RCR plus NCR plus 1 times R plus 1 CR. Since x to the power r and x to the power r, they are like terms, you can just add up the coefficients. And then the next x to the power r, the coefficient is this one. So plus NCR plus 2 times R plus 2 CR. which means you have to sum up all the coefficients of x to the power r. The first one is NCR, RCR. And the next one is r plus 1, r plus 2, r plus 3, all the way until you got the term NCN. How about the multiplication part? Because we are looking for x to the power r, therefore it should always be whatever CR. For the NCR term, it should be NCR times RCR. For the NCR plus 1 term, it should be R plus 1 CR. For the NCR plus 2 term, it should be times R plus 2 CR. Okay, therefore the last term should be NCN times NCR. After so much efforts, we eventually have obtained the equation which is required by the question. Question 2 is about combination. The question tells you that there are 23 people and they are applying for a committee of 4 people. There are 2 selection processes. The first one, they select at least 4 people out of these 23 applicants. And in the second process, they chose 4 people out of the group into the committee. To select n people out of 23, the number of combination is 23cn. And in this question, n should be greater than or equals to 4, because the question tells you that the selection should be at least 4 people, which means if you first choose 4 people out of this 23 people, it should be 23C4. If you choose 5 people out of 23 people, it should be 23C5. In selector B, because we have n people in a group and you only choose 4 to form the committee, therefore the combination is NC4. Theoretically, it is simple because you just get the product of these 2 will do. But the problem now is the n is changing. It can be 4, can be 5, can be 6. It can be all the way up to 23. The total number of ways of selection process becomes like this. 23C4 if you choose 4 people in selector A and then have all these 4 people into the committee. Or you choose 5 people from selector A and then out of these 5 people, you only have 4 into the committee, and so on, all the way. You can choose all the 23 people from selector A and then assign only 4 people in selection B. Okay, but how to evaluate the sum? Now the result from part 1 becomes handy because NCR times RCR. If n equals to 23 and then r equals to 4, the next term should be 23. Here, 4 plus 1 is 5. 23C5, and then 5C4 is this one. Again, n equal to 23, r equal to 4 is 23C6, and then 6C4 is this term. All the way to the last one, 23C23, and then 23C4. The sum of this actually equals to 23C4 2 to the power 23 minus 4. Then the things becomes simple. You just apply this into your calculator and you will get to the answer. Question C1 asks you to show that the blue triangle and the pink triangle, they are similar. Of course they are similar because angle A is the common angle of these 2 triangles, and then for each triangle there is a right angle. So angle ACD should be equals to angle ABC, because angle sum of triangles, 180, you have 2 angles equal. The third one must also be equal. Therefore, these 2 triangles, they are similar due to AAA. Question 2 asks you to show that this x is actually equals to A times B divided by C. From the result of similar triangle, we know that all the sides are correspondingly in proportion. Therefore, the result is obvious. As you can see in question 3, the figure is quite similar to the figures that you are doing in part 1 and 2, except that the figure is replicating itself, getting smaller and smaller each time, which means there are many pairs of similar triangles. The question is asking to show that the areas of all these quadrants, sum them up, should be in this form. The area of one quadrant should be x is the radius, so x squared pi times 1 over 4. The next quadrant should be x1 squared times pi times 1 over 4, and so on. So we all have 1 over 4 pi. We can take it out as a common factor, and then what's left inside bracket should be x squared plus x1 squared plus x2 squared. Since this x, x1, x2, it comes from a side of a triangle, and these triangles are similar triangles. It's quite logical for us to believe that they are in proportional, which means the later term divided by the previous term should be in the same ratio. If we can show that, then this x1, x2, x3, infinite number of terms, they are in geometric sequence, and sum of a geometric sequence is not difficult to be obtained. Our next target here is to show that these terms, they are really in geometric sequence. x1 over x is actually equals to x2 over x1. And then from this figure, we know that the red triangle should be similar to this green triangle. So x1 divided by x should be equals to AF divided by AC. And this AF is actually equals to the B minus this x, because this is a radius. If CD is x, then CF should also be x. And we have this equation formed. B minus x over b, we can rewrite it into b over b, which is 1, minus x over b. From part 2, we know that x equal to ab over c. Now we can see that if we multiply the numerator and the denominator by 1 over b, then b can cancel out each other, and the numerator has only a over c left. The denominator becomes 1. So what we have done here is the ratio of x1 to x should be equal to 1 minus a over c. Now let's take a look at the ratio of x2 to x1. These triangles APQ and AHF, they are similar. Therefore, the ratio of x2 to x1 should be equal to the ratio of AQ over AF. AQ should be equal to B minus X minus FQ, and FQ should be equal to X1. Therefore, the ratio we have here, X2 over X1, should be equal to AQ, B minus X1, over AF, which is B minus X. Let's replace X1 by X. From the previous ratio, we know that x1 over x is equal to 1 minus a over c. Therefore, x1 should be equal to 1 minus a over c, the difference times x. And then rewrite this fraction into b minus x over b minus x, which is 1, and then minus this term over b minus x. We now replace the x in the form of AB over C, which we obtained in part 2. Now, if we take out the common factor of B, it can be cancelled with the B in the numerator. The denominator now becomes 1 minus A over C. And now you can cancel the common factor of 1 minus A over C from both the numerator and the denominator to obtain the ratio of x2 over x1 equals to 1 minus A over C. Just like what we have anticipated before, the ratio of x1 to x is equal to the ratio of x2 to x1. They are in the ratio of 1 minus a over c. Now we have just proved that x, x1, x2, x3 all the way, they are in geometric sequence with the ratio 1 minus a over c. the square of each term, x squared, x1 squared, x2 squared, x3 squared, they are also a geometric sequence with the ratio 1 minus a over c whole square. Let's now study the ratio first. A over c, it is talking about a over c. This should be sine a. Therefore, 1 minus a over c should be equal to 1 minus sine a. Everybody knows that sine a should be less than 1 because a is one of the angle in a right-angled triangle. So 1 minus a must be less than 1. 1 minus a less than 1 number, which is a positive. So the difference must be always less than 1. The square of this 1 minus sine a should also be less than 1. Therefore, we now know that this x squared, x1 squared, x2 squared, all the way, it is a geometric sequence with the common ratio less than 1. The sum of this sequence should be equal to the first term, x squared, over 1 minus the ratio, which is 1 minus a over c whole square. We have just obtained the sum of this geometric sequence, and we are going to change this sum in the format requested by the question. So it's not that difficult now because we have everything ready. X from part 2, it should be AB over C. So we change it to AB over C and then expand the bracket, 1 minus A over C whole square in the denominator. You would have 1 minus 1, 0. And the minus become a plus. So plus 2A over C. The minus and plus here become minus. So the denominator become 2a over c minus a squared over c squared. And we have both 1 over c squared in both the numerator and the denominator. Therefore, we multiply c squared to both the numerator and the denominator, and we will obtain this a squared b squared in the numerator. And the denominator, this term, it becomes 2ac. Here minus a squared over c squared, you multiply the c squared, it becomes minus a squared. As we can see, we have a in both the numerator and the denominator. Take out the a from the denominator as a common factor and cancel it out from the numerator, since we have square a in the numerator. So after canceling out, it becomes a. The denominator changes to 2c minus a. This is the format required by the question. In question 4, it asks to show this inequality. In section 3, we have just obtained the areas of all these quadrants. Since all these quadrants are within the triangle ABC, therefore the triangle area ABC should be greater than the sum of all the quadrants, which we obtained in part 3. Area of a triangle ABC in specific should be equals to 1 over 2 times the product of any two sides times sine of the included angle. So here we have 1 over 2 BC sine A should be greater than the area of all the quadrants. Then we know that sine A should be equals to A over C. So we replace sine A by A over C, and then we can cancel the C. What's left on the left-hand side is B times A over 2, and we didn't change anything on the right-hand side. Let's now compare the result we obtained here with the requirement of the question. On the smaller than side here, you can see we only have pi over 2 left. On the greater side, it should be 2c minus a over b left. Therefore, let's change accordingly. First of all, we have AB on both sides of the inequality. AB represents the length of two sides of a triangle, and therefore they should both be positive. And we can cancel AB from both sides of the inequality. Since we only want pi over 2 on the left-hand side, and therefore all the other things you have to take it away by multiply something. Pi over 4, by multiplying 2, you would make it pi over 2. Then this b over 2c minus a, it has to disappear. Therefore, we multiply 2c minus a divided by b to cancel them out. And then since this is an inequality, we have to make sure that what we multiply must be positive. B is positive, of course, but how about 2c minus a? C is the longest side of this right-angled triangle. So C itself should be longer than A. C minus A should be positive. Now you have 2C minus A. It is guaranteed to be positive. Therefore, now we can multiply both sides of the inequality by this expression and still maintain the property of this inequality. And then we get to the answer required by the question.